Guys, it's about 7:32. We'll go ahead and kind of get the train rolling here, and hopefully we get some more folks that jump in here. Looks a little light tonight. Welcome to the May version of the Atlanta Radio Club monthly meeting for 2023. Have another great program lined up for tonight, and we'll get to that in just a moment. We'll go ahead and let, for those of you that are here, let's go ahead and let Stephen give us a repeater report, and we'll fill in for anybody after that that might need a fill in from his report. But I guess, Stephen, go ahead for now, and what you got?
Okay, so 2 weeks ago, Jeff and I deployed the new RC210 repeater controller and its associated hardware, and I think I've got most, if not all, of the bugs worked out of the programming. So the Sunday night net's working correctly. The Southeastern Link repeater net is working correctly. The only functionality that we have lost is the National Weather Service can't bring up and take down the link on their end as of yet. There's a chance that in order to do that, it might require another RC210, so it has its own DTMF decoder. But we'll cross that bridge if we come to it. And let me know if y'all hear any weird controller behavior. I know there are some rogue error messages that are being sent out every once in a while. I think I've curtailed most of those. And the repeater sounds great to me. I do intentionally set the audio levels a little low on it, so that way we don't bleed over into the 805 repeater, which has been an issue in the past. And also, the Echo Link is still functioning as normal, and none of the control codes have changed. So #1 is still the Echo test. 4682 is still the DTMF test. #4 still tells you the time of day, and the 560 commands for Echo Link work, and the codes to bring up an Echo Link node or take it down are the same thing, just CC2# to activate Echo Link, and then CC whatever node number, and then pound to connect to the node number, and then CC pound to drop the connection, and CC pound again to turn the Echo Link node back into standby. You don't really have to do that. It'll go back to standby on its own, but that's pretty much the way the lay of the land right now. I've got some documentation to update, and I do need to move some macros around so that everything's where it needs to be. And I still need to get the DVR tracks in there, but that controller doesn't support uploading DVR files over the serial port. So that has to be done either over the air or by making a control cable and going up to the tower and uploading all of them. There may be a way around that, though. I'm just going to have to do some thinking with Jeff. And I think that's pretty much it.
Right. Thanks, Stephen. A lot of hard work there, and we appreciate what you do each and every day, actually, for the repeater. So thank you very much. All right, well, let's
another feature is we have remote programming of it via a Windows programming interface, so no more command line.
Okay. Sounds like a winner. All right, let's go ahead and I'll turn the meeting over to Rob, KI4UTY, our programs manager, and he's gonna lead us into tonight's another great program that he's got lined up for us. If you have any interest in anything in particular that you'd like to see us do on a weekly meeting, monthly meeting, please do get in touch with Rob and give him your ideas and let him, the more you give him, the easier his job is. So if you know somebody that you've talked to that's willing to do a program for us, then by all means, get with that person and also get with Rob and try to help Rob out and make his job easy and get us some more interesting programs. And that way we're bringing what you want to hear and see, and we keep things rolling as to what the membership wants to see. So let Rob, KI4UTY, I believe his email is KI4UTY@atlantaradioclub.org. And I'll give it away to Rob and let him confirm that, and take it away, Rob.
Yeah, make sure I'm not on mute over here. Don't you have you don't have an announcement before we do that?
Yeah, I guess we can go ahead and let the cat out of the bag. We met last night with the Hamfest coming up, and just to give you a quick short synopsis, table sales have been very slow this year. They're dribbling in, and we still have a lot of unsold tables, and there's a lot of other things that are going on behind the scenes in the background, things that we're hearing. So we met last night and we discussed the Hamfest for this year, and so that it's not a financial detriment to the club, because we lost quite a bit of money last year, and last year was a very rough year with everybody canceling on us at the last minute, and it's really made this year rough too. So we decided that we're going to cancel this year's Hamfest, so that we've at least got some time to because we're about a month away, and we need to let people know so they can change their plans and all that. It's not something we do lightly. One of my biggest concerns is having a half empty building again, like we did last year, and we had already upset a lot of people last year, and I didn't want to do that for the second year in a row. There's some discussion as to whether canceling it's necessarily a good thing either, but sometimes keeping it so that somebody doesn't show up from a long way away, and then the show's not up to snuff, and they go home with bad things to say, and that's all people hear about the show afterwards. So sometimes canceling it might be the best thing to do. And we've got to be careful with our financial resources in the club. So unfortunately, that's a decision that the board didn't make lightly last night. So just to let y'all know that we will not do the Hamfest on June 3rd, I think it was, for Saturday. We're going to get to work on next year's show. We're going to try to come up with some things, figure out where we're going wrong on some stuff here, why the tables are not getting filled up. We've got we already have a lot of ideas on some things. So well, we've got a work cut out for us next year, and we need volunteers to help do things. So if you have an interest in seeing how Hamfest works, now's the time to let us know. You can email us at president@atlantaradioclub.org, or you can email xcom@atlantaradioclub.org. Let us know that, or Hamfest chair at Atlanta Radio, let us know that you'd be interested in helping out for 2024. We're going to have, like I said, we're going to work on some things to make next year's show a really good show. And obviously the planning is going to start right away on that, because we've got our work cut out for us. So anybody have any questions about that? All right. Like I said, it was not, not an easy decision to make, but I think it was probably in the best interest of the club financially. And we're going to work on making 2024 a good year. So, all right. Well, if nobody has any questions on that, I'll turn the show over to Rob and let him take it away for the program for tonight.
All right, thanks, John. Yeah, I appreciate that. We've got another good speaker, another excellent speaker tonight. He comes highly recommended, and I think that you'll agree with the recommendation. He's president of the Long Island Mobile Amateur Radio Club, Limark, in New York, which if I still lived up there, that might be the club that probably the club that I would be in. And it's a pretty big club from what I hear. And so he's made this presentation to his club and also to the 2023 Ham Radio University. You know, he won the presentations there, and you know they don't let just anybody present. So this should be great. We heard some good. Michelle, one of our members, said that she saw it and it was excellent. And yeah, so I'm looking forward to that. So our speaker tonight is Richie Cetron. Did I pronounce that right, Richie?
Yes, it is correct.
Right, K2KNB. And with
Correct.
that, I will turn it over to you, sir.
All right, so thank you very much.
Could you try
And,
again?
oops. Did somebody else say something?
Yeah, my Siri.
Okay, sorry about that. All right,
Go ahead.
it is interesting, just to digress for a moment, because it would be an interesting thing to have my club get into a video Zoom with your club, because many of our problems are similar. We're, just to mention, we have an operating budget of $21,000 a year. And of that, the essential part of it is about 17,000. We average between 350 and 400 members a year, but we need Hamfest to cover the balance. And, you know, we're missing vendors and people die and they lose interest. And we have very similar problems. We run 8 repeaters in Limemark, a whole bunch of other things. Anyway, might be an interesting session for you guys. So a quick background, I'm licensed since 1958. A lot of years as a technician, life got in the way, a whole bunch of things. 2003, I got my general. 2006, I got my extra. I've been the president of the Long Island Mobile Amateur Radio Club for 13 years. Nobody wants the job, basically, and I'm sure you experience the same thing there. And in fact, it's difficult for me to get a vice president because the vice president knows if something happens to me, he becomes the president and he doesn't want it. So I usually have to sign a contract that I won't die or resign during my term in office, and then I can get a vice president to do something for me. Anyway, what we're going to see, and I hope that I know my presentation is up. Are you sharing, letting me share screen? Yep. No. Gotta share screen.
Should have it. Go ahead, try to get it. Clicked on the button.
Got it this time.
Okay, good.
And let me just, okay, I have to make sure that I'm going to come up in the right area here, and bear with me.
Hello?
Phet.edu. Now, again, what I had presented, let me just make sure that it's, I had prepared something, but I think it had to be up and running. Phet.edu, great for simulations, and I use it all the time. And we're going to start with a quick demonstration. We're going to take 2 wires. We're going to take a battery. Never get it really straight. We're going to take a lamp. And we're going to connect it. I did that backwards. Hold on. All right, DC bulb lights, constant lighting, very simple circuitry. Now we move on to an AC circuit. And the reason why we do this is that because what we're going to be talking about in RF is an AC circuit. And many of the characteristics that you'll see here are exactly what occurs in an AC circuit.
Hey,
We're
Richie,
going to take our
you're
circuit.
seeing the URL. Is there some
Say,
other you're looking at?
I believe it's I have it at the end. It's phet.edu.
Right. Okay.
It's from the University of Colorado.
I mean, are you showing us something there?
Oh, you're not seeing me now?
We're not seeing.
Okay, hold on a second.
Yeah, whatever you're showing the simulation of.
Okay, You're not seeing the screen right now, correct?
Seeing, yes, the click to add title and the URL.
Oh, and it didn't show the simulation. Okay. All right, I'm sorry about that. Then I don't want to waste a lot of time doing that. I thought, okay,
Got to click.
I just knocked myself out. All right, hold on.
I know, I want to see it.
Yeah, well, see, the thing is, this should be my simulation. No, hold on, bear with me. You know, I'm an old dog. Sometimes you get new tricks. Let me go one more time here. Oh. All right, I think I know what the problem is. Okay, that's what happened. It closed. Okay. Do you see that screen now? Are you seeing click to add screen?
Yeah, click to add title.
Okay. So again, I don't know if I'm going to get into the simulation. Are you seeing a simulation screen come up now?
Not yet.
Yeah, then there's a problem here, and it's I'm going to skip it rather than waste a lot of time doing it.
It appears you're showing the application rather than the desktop and you're unable to switch
That's-
between apps.
That's what I was trying to do. Well, that's it. But the application was built into my my presentation. So let me go on. If I can come back to it at some point. If I get out of this, I can go into simulation. Okay, we're dealing with connectors and cables, and this really has been something of interest to me. Mostly self-taught, but sometimes you ask questions about things and you find out things. And honestly, it's one of those topics where one thing leads to another, leads to another. Why is this important? Well, you have a transmitter, the transmitter is giving you your power, your wattage. It's a positive. You have an antenna that generally will at least give you whatever power is getting out there, or it can give you additional power. But no matter what you do, you are going to lose something in your coaxial cable. It doesn't matter. You can have the most expensive cable in the world, you're going to lose something. You're going to lose something because you have connectors. And these losses are called attenuation. These losses are measured in dBs. And what I find sometimes is people get involved in conversations and they kind of shake their head because they're not really into it. And it's really important. dB is a logarithmic function. And just for the basic numbers that we deal with, if you have a 3 dB loss, you're going to have half your power. If you have a 3 dB gain, you're going to have twice your power. 6 dB is going to be half of a half, it's going to be a quarter, and a 10 dB will be 1/10. But these are just basic things to understand that it's taking power away. And that's what we're interested in, not the gain, but we're interested in the loss, because that's what's going to happen in cables. It's taking power away from what you've put through the transmitter, put out in the transmitter, getting to your antenna. And the question is always going to be, how much are you willing to lose? Now, insertion loss, everything that you put into that cable, everything, whether it's a connector, whether it's the SO239 on the back of your transceiver, whether it's a watt meter, filters, they all have a loss. They all produce a loss measured in dBs in your cable. And from a practical point of view, this is my house. And you can see over here power lines, and there's power lines behind me. So when it came time to put up my gap tighten, here it is on my shed. I have a sidewalk here. So I went underground come up here, I come up along the side of my deck, come up over here, up over this roof, and on the other side of this roof, going in at opposite to this room over here, is my shack. My cable went bad, exposed to ultraviolet for 20 years. The jacket came off, the braid was exposed, it was a real mess. Well, I wanted to get my antenna up and get it functioning properly. What I did was I jury-rigged it to pick up my buried line. I have buried cable going, actually going from here to there, but to pick it up, I cut off the bad cable over here, put a jumper in to get to my antenna. And the same thing over here, I had cut off cable, put a jumper in to get to the remaining part going up on the roof. Okay, simple enough. 3 connectors, 3 connectors, whoops. 3 connectors, 3 connectors. When you go up on my roof and over, another 3 connectors outside, another 3 connectors inside, and finally the SO239 on the transceiver. There's 19 connectors. And I'm one that will always tell people, don't worry, a connector has an insertion loss of 0.02 of a decibel. That's nothing, right? Really seems like nothing. And I tell people, don't worry about it. But wait a minute, this is my setup. And suddenly I have 19 connectors in there and say, oh my God, this is really going to be terrible. Well, the 19 connectors equates to about a loss of 8 watts. We're just talking connectors now, but a loss of about 8 watts. So what am I worried about? So if you have to use connectors, that's one of the things that I want you to know. Don't be afraid to use connectors. If it's easier to use a right angle connector than it is to feed it into the house, just go ahead and do it. By the way, I'd point out, you know, the solar panels giving me a lot of interference, but they came long after I put up the antenna. Another factor, my neighbor's house, aluminum siding. Fortunately, there's no part of their house in which I would get reflection back to the antenna. It would all be angled. But bear that in mind when you're placing your antenna. My specialty is not antenna, but just bear those things in mind. And of course, with these wires here, it limits my drop zone off the roof. I do have a tri-band vertical up here, but I would not be comfortable putting a beam when my high power line is coming in right at my chimney there. Okay, one of the problems with hams is that they look for cheap stuff. No question about it. So you go to a ham fest and you find a hank of wire like this and say, all right, listen, the guy's only asking $5 for it, I'll take it. Well, this is a little bit of a problem here because as, you know, we all take wire, sometimes we wrap it around our elbows and whatever. There is what's called a bend radius. We'll learn more about that. But if you begin to get a pinch in the cable, it's still going to function, but it's not going to function as well. So if you go to a ham fest and if you're buying cable, and particularly if it doesn't have connectors on the end of it, you know, take a good look at the cable and make sure that the copper looks like really fresh copper. It's not oxidized, but be careful when you buy used wires. And be careful when you have your own wires and you wrap them too tightly, you will damage the wire. All right, so what are we talking about? We're talking about RF. RF is the alternating, oscillating signal that comes out of a transmitter in the range of 3 kilohertz to 300 gigahertz. And you can see expressed as it is. That's the range of RF, and that is when something particular happens to an AC circuit. And what's happening is we're going to have this electromagnetic field that's created, and we'll talk about that. What does it actually come down to? Well, you have the formula, and I'm not one for formulas, and I know people can go to sleep immediately with a formula, but you know, you want to know how to figure the length, and you know the relationship between the length of the wavelength and the frequency of the wavelength. And you can get some idea from what I have here about, first, the velocity. We're talking about the velocity of light in a vacuum at some close to 300 million meters per second, or 186,000 miles per second. Excuse me. And you can see that in this 3 kilohertz, 3 kilohertz, which is the same as 3,000 hertz, you can see the length of a wave. And conversely, but in the 300 billion cycles, you can see the length of a wave. And although we're not really dealing with this kind of thing, it's significant, as I will explain to you later. Electricity is fast, traveling at the rate of, as we just said, 186,000 miles per second, or close to 300 million meters per second. But nothing is instant. No matter what you're doing, that circuit, that current is traveling some distance. It could be a foot, it could be 20 feet, it could be 1,000 feet. It takes time. It's just a matter of how you're going to actually measure that time. Okay, basics on wires. Most coaxial cables have, well, there's a variety of cables. Some have a solid connector, some have a standard connector. When you're connecting to a solid connector, you're connecting on the tangent of the connector. So you're screwing it down at this point, you're screwing it down at this point. Not a lot of surface area. I keep doing say sorry about that. But when you get to the shielded cable, you see the surface area that you're getting. And so therefore, for example, when you're making a connection to, I think maybe it's a TA33, maybe that uses screw terminals, or any antenna that uses screw terminals, your preference might be to put a stranded wire in there to get the best surface area and therefore the best connection. Okay, the rule of thumb for magnetic fields in the wire, I think you're all familiar with that. Right angle to the flow of the current. Now, this was part of the pictorial that I would have shown you. How do we know that there's a field around the wire? Well, we use or can use a clamp-on ammeter. And you can see, although this again is just a pictorial of it, but you can see that it's clamped around the wire. What's happening is there's a relationship between the magnetic field and magnets that are in this ammeter, and that movement, that magnetic field movement pushing electrons in the ammeter is what's going to give you a reading. Now, let's say you wanted to take a reading on your wire in the house, you'd have to separate the wires, because in your electrical wire in the house, your electrical cord, they actually cancel each other out. You wouldn't get a reading. So you separate the wire and then take your reading to check your ammeter. The electromagnetic field is the field created by the interaction of the electric field and the magnetic field. They are perpendicular to each other. They're perpendicular to the direction of the voltage, and they peak and ebb at the same time. And this is the wave that will be traveling in your coaxial cable, which will ultimately get to the antenna and help to resonate the antenna. But it's a wave, and that's why everything that is in the cable becomes important, because they would influence the wave, have negative effects on the wave. The left-hand rule gives you an idea of this, I guess you call them the vectors, where if you do the left-hand rule, you can see even in your own hand that you have three forces and they are all perpendicular to each other. And then you have a magnetic field, which is actually creating polarity in a North Pole and a South Pole situation. Again, this is what is actually going in your coaxial cable. So let's look at the coaxial cable. Center conductor, usually we'll deal with some of the materials later on, but center conductor. Around the center conductor is a dielectric, something that does not conduct electricity, also called an insulator. Around that is a braided shield. This braided shield is what is keeping RF in, keeping RF out, and generally we could refer to this as a Faraday cage. It's just containing everything. Finally, a jacket around it for UV protection, waterproofing, a whole bunch of things. Okay, so what's going on in the coax? Well, you have reactance, you have resistance, you have conductance, that's just the ability of the particular metal, and you have velocity, and the velocity is what speed relevant to the speed of light is actually going on in your cable. So resistance versus impedance. Wire itself does not have, most wires don't have a particularly high resistance, but they do have resistance. And because of that, let's say in your home circuit, where you might have a 15 amp circuit with a number 14 gauge wire, at least the code up here, and I'm pretty certain it's universal, is to have your sockets no more than 50 feet away. And the reason for that is just the normal resistance of that wire will cause about a 5% loss at 50 feet. 5% won't necessarily affect a light bulb, but it will definitely affect a motor. And so that is generally coded at 50 feet. Now that's the resistance in the wire. But in an AC circuit, you begin to get something else happening, which adds to the resistance. And I just want to see how I do. And this is called inductive reactance and capacitive reactance. And in this case, the word reactance means they're reacting to something. And again, it's that something that's in the cable, that's in the oscillating circuit that we're trying to protect and trying to make sure we're getting from point A to point B with a minimal amount of interference. So now you have inductive reactance. An inductor is any coil of wire and almost by definition, any piece of wire. And what happens is in the AC circuit, you have current flowing through this wire and then you're changing direction. And the inductor say, I don't want to do that. I don't want to be changing direction. And there's a resistance to that change. In the formula, and again, of course, it helps to explain certain things, not that you're going to memorize every formula, it's not necessary. But here's your reactance of your inductance. Here's your frequency. As this frequency gets higher, it increases the amount of inductance. So regardless of what the native inductance is of the coil or whatever, the fact is it's going to get higher as you increase the frequency. Capacitive reactance, any two wires separated by a dielectric are a capacitor, and a capacitor stores charge. Well, the same thing, you're alternating the charge, you're going back and forth as the current changes direction. And as a result of that, again, you have some resistance. And I should have mentioned as a bottom point here, that it's measured in ohms. So whatever number you come up here for the inductive reactance is measured in ohms. Whatever formula you come up, whatever figure you come up with in the capacitive reactance, it's measured in ohms. Notice here that the frequency is in the denominator. Therefore, the higher the frequency, the smaller and smaller the fraction will become, the less the capacitance, and the easier it will flow through the circuit. And that's the balance that has to be created in a coaxial cable. Increased inductance will slow the circuit down. Increased capacitance will counterbalance that. So if something happens in the circuit and you get to the end and you have an imbalance between the capacitive reactance and the inductive reactance, that's where an antenna tuner comes in. You're either adding capacitance or you're adding inductance. One of the things that happens in the AC circuit that we're talking about is that the electrons, as they're flowing through the center conductor, they want to be to the outside. And there's a whole bunch of physical reasons for that, but they don't want to be in the center. They want to be to the outside of the inner conductor. And they're also going to be in the shield. Well, this is a better picture of it. All of your electrons are basically here, and there's nothing here. So if you take any gauge of wire, 10 gauge, 12 gauge, 20 gauge, bear in mind that the electrons are going to the skin and thus cutting down on the actual gauge of the wire in terms of the ability to handle power. So even though a wire may, by theory, be able to handle a tremendous amount of voltage or amperage, in reality, in the RF circuitry, it runs into a problem. It's going to the skin. And again, it comes down to the same thing dealing with solid and shielded wires. A solid wire, or let's say the stranded wire, because it's stranded, gives you much more surface area, and therefore will very often have better power handling capacity than the solid wire, because this is limited to whatever surface area is here, and this has multiple surface areas. Each of these wires becomes its own surface area. Well, if you don't need the center, then why have a center? And so you have cables in which the center is totally eliminated because it's totally unnecessary. Here is what is carrying the flow. In this particular case, smaller, but again, that's what's carrying the flow. Now, of course, you also have the option of putting something else in the center. You might put aluminum in there to keep the wire on the lighter side. You might put steel in there to make it stronger. That's the option of the manufacturer. But that I always found to be really interesting, that you simply don't need the center of the wire. This is, in fact, the circuit of a coaxial cable. Each of these would, in theory, represent 1 foot, because that's how the coaxial cable is measured. Within every foot, there is capacitance. Within every foot, there is inductance, both in the center conductor and in the shield. And this just goes on and on and on and on and on. And what this cable is supposed to do is to be consistent, whether it's 1 foot, 100 foot, 800 feet, to have a consistent thing called characteristic impedance. The characteristic impedance, which is called Z, is the total resistance that you would find in an AC in this coaxial cable in an AC circuit. So now you're taking the resistance of the wire along with the capacitive reactance and the inductive reactance. That will give you the capacitive, that will give you the characteristic impedance, and that can be controlled. You can make any characteristic impedance based upon what your needs are, what the engineering needs are. But for ham radio, there's 3 basic characteristic impedances that we deal with. One is 50 ohms, 75 ohms, and 93 ohms. And there are reasons which, for some of them, I'm not sure why they came up with those numbers, but we do know that in ham radio, it was to be a compromise, because these are 2 of the most popular type of antennas in ham radio. And that is the, excuse me, you have a 36 ohms in the ground plane, and you have 72 ohms in a dipole. That's just the laws of nature. That's the way it is. Well, you weren't going to have one cable for the 36 and one cable for the 72. And so the compromise was 50 ohms. And for most cases, it works fine. In some cases, you bring in an antenna tuner and it works. When I first started to learn about characteristic impedance, I was told, well, it's the ratio between the outer conductor, the outer side of the, the outer side of the inner conductor and the inner side of the outer conductor. So we're talking about this distance in here. And, at first I kind of just accepted that. And I said, well, okay, it's just a distance. But then you realize that this area in here is the dielectric. So we're talking about how much dielectric is really in existence between the outer part of the inner conductor and the inner part of the outer conductor. This is a graphic not necessarily meant to be accurate, but in a 50 ohm, the red being the dielectric, originally they thought 30 ohms might be ideal for power handling. But if there's a skin effect, and if you have a lot of the magnetic fields on this edge, well, you also have them here. And so if you come too close to the shield, you're risking shorting out the wire. And on the other hand, the 75 ohm, as you increase the space, you're also decreasing the amount of capacitance, which has made it very good for the use of videographers and video cameras. This is an LMR display board. You can see the differences. Some of you have probably used it. LMR 400 is extremely popular, double shielded wire. But what these all have in common is that they are all 50 ohm cables. So it doesn't matter here or here, they're all 50 ohm. And what that means is that if you take a connector from this cable to this cable, you have a minimal insertion loss, just like any other connector. And so that's why, for example, if you're running cable to your house and you're using a stiffer cable like an LMR 400, but you're getting it a transmitter and you can't get near it, you make a jumper. You make a jumper out of something that's flexible, you get the proper connector to connect the two, and you haven't affected anything other than the basic insertion loss, which we've already mentioned. So if it's 50 ohms, it's 50 ohms, doesn't matter the size, because it's 50 ohms because the ratio between the inner conductor and the outer conductor has remained the same. And here's a perfect example of a large, probably could be an inch, 7/8 hard line up here connecting to an end connector. It's not going to affect anything. Of course, you want to be careful how much power, because you're obviously running a lot of power through here and perhaps not so much here. But again, so it really doesn't matter. So don't be afraid. I said to someone, I'm not going to use an RG8X for a jumper because it's going to be so much loss. And they looked at me and they said, no, the loss is by the amount of cable that you're using. If you're using a 6-inch cable, that's what it is. It's 6 inches. If it's a 12-inch cable, it doesn't matter. It's by the foot. Don't worry about it. And this is, again, just a formula for the characteristic impedance. But you notice again that there's a relationship between the inductance and the capacitance. But again, I'm not one for formulas. All right. The materials of the center conductor: silver, gold, copper, copper-clad steel, copper-clad aluminum, doesn't really matter. The best conductor actually of all these is actually silver. Probably copper is best. Copper is second, but we're not really going to do much. We're not spending our money on silver. But these are the conductors that make up the center. Those are the materials that make up the center conductor. The insulating material, again, it doesn't allow the electricity to pass, but it takes charge. The material itself will take positive and negative charges, but not allowing electricity to pass. And air is a dielectric. Air doesn't conduct electricity. Some of these other things you're familiar with. And Teflon is my favorite because that Teflon is polytetrafluoroethylene. So anytime I'm at a party and people are getting dull, I just say polytetrafluoroethylene and I become the center of attention. Okay. As far as the braid goes, it's copper, it could be copper-clad aluminum, it could be foil. You could have one shield, you could have 2 shields, you could have even 3 shields. That's your Faraday cage. That's keeping your RF within the cable, stopping other RF externally from getting into the cable. Now, this is not coaxial cable. I think this is actually shielded shielded audio cable. But remember how small the radio wave is when you're up in those. Well, we should give me an example of 300 gigabytes. You can see this is not a particularly great braid here. It doesn't have to be. It's not handling the RF. But you can see a space there. That space is actually larger than some of the waves, some of the radio waves that we're talking about. If this were practical coaxial cable, the end result would be you'd have radio waves escaping from there. So, and the jacket's not going to stop them. So that's why the braid becomes significant and relevant to whatever frequency you happen to be working on. As far as the jacket goes, again, pretty common materials. But one of the materials is this neoprene, which is pretty expensive, but you have to use that or you, well, I was gonna say you have to use it, but it's waterproof. If you're really burying things in water, you have to be real careful. And that's what happened. I should have mentioned, when I had some work done around my house, that distance between the shed and the house, I had them bury a 2-inch pipe about 2 feet in the ground. And I said, that's really great because now I can run inexpensive wires. I don't have to get crazy. But the reality is a pipe buried 2 feet in the water, 2 feet in the soil becomes a water holder. Why? Because ground temperature remains constant at 55 degrees. So in the wintertime, it's warmer than the air. In the summertime, it's colder than the air, and water just collects. So when I run cable through that pipe, it's got to be waterproof cable because it's going to be sitting in water. Don't forget about the ladder line and twin lead. In this particular case, the dielectric is the air and the material that's between them. But they're not shielded. And so while many of us would use this as part of our antenna, you have to be very careful not to let it get in touch with metal. You have to be careful going around aluminum drains, anything else, because that will affect it. Now, the radio waves, the RF waves, they want to be in a very consistent tube. And so in a perfect cable, they go straight, there's no problems. They will accept a bend. And there's what's called the bend radius, which is the minimum amount that you can bend your cable and still have the flow be pretty consistent. But once you start to make a sharper turn, you begin to get the radio wave coming back. You begin to get your SWR increasing. And of course, if you make a complete right angle, you're going to get most of it coming back. That's not what you want. A little later, you'll see a right angle connector, but what you actually have in a right angle connector is a very thin piece of wire that makes this gentle bend. And the wire, cable can handle it. And again, it's such a short distance that it's really not going to have any effect on anything as far as your dB loss goes. Now, RG213 is a very popular cable. Whenever you're buying cable, take a quick look at the specs, and you can get a pretty rough idea of this one. You can see that, what are we looking at? You can see the kind of braid it is. It's a copper braid. You can see the gauge of the wire. You know, a 13 gauge wire being similar to our 14 gauge wire, you know, it certainly can handle a whole bunch of power. And there's other things about the cable. They'll usually give you the capacitance per foot, the inductance per foot. They'll give you as much information about the cable so that you know what you're dealing with. They'll tell you about the flexibility. You know, can you make turns with it? What's the minimum turn ratio? So whenever you're looking at cable or before you go to the store, before you order online, take a look at the characteristics of it. And the velocity is the speed with which the electromagnetic wave is traveling through the dielectric. And 66% is pretty good. 70%, you're not going to find it much higher. It is being slowed down. Now, of course, it's being slowed down by the speed of light, but what that means is that the electromagnetic field is actually, the electromagnetic force is actually traveling at 66% of the speed of light, which means it's not getting to where you would think it would get as fast as you think it should be getting there. You want to be aware of the velocity. Most good cables will be in this particular range, but again, be aware of that. All right, just a quick, simple thing. A 13 gauge wire can handle approximately, what do I have there? It's 18 amps at, what do I have there? 120 volts, I'm sorry. So, you know, multiply the two together and you get some idea of what a 13 gauge wire can handle. Now, we're not really up in that levels for the most part, but it gives you an idea of what it can handle. 100-watt transmitter. That was an interesting thing, you know, one of those dumb moments. You know, we put out 100 watts, most of us are probably doing 100 watts. What does that equate to in volts and amps? You know, it seems like a lot, but in the scheme of things of even electric in the house, it's really not a lot. And it's really about 76 volts and 1 point something amps. Really not a lot. So the wire needs are not anything what you would necessarily think about. But just bear in mind that the amount of the wire, the capability of the wire to handle high power is something that you need to know when you first go out to get your cable. Also, frequency affects the limits, as we kind of saw with the inductance and the reactance, but the higher the frequency, the more the electrons are flowing to the edge. As they flow more to the skin effect, less of the semiconductor is available to conduct, and therefore it gets hotter, and that's when you can have a meltdown. Okay, typical cables. In this particular case, look at the power handling of a variety of cables at various frequencies. And you can see that as the frequency increases, the amount of power that can be handled decreases. So one of the things that you want to do is to look at how much power a cable can handle. And in my case, for example, I use 213, or I also use 9913, 9313, 9213, I'll get that right. But I wouldn't use RG8X if I was going to use more than 100 watts. And when I set up initially, I did have a 600-watt amplifier. So therefore, knowing that I'm going to be doing 600 watts, why would I spend money on a cable that's going to be totally functionless? And the fact is that that cable could go through severe breakdown at that kind of a power. So as you're choosing, get some idea of where you think you're going to be. Maybe you don't have an amplifier today, but you plan in the 6 months to get an amplifier. Make sure that you're getting the cable that's going to be suited for that purpose. Now you have dB loss per foot, per 100 feet, I'm sorry. And again, you can see at various frequencies how much loss you have in dBs. And again, you have to decide, are you going to be transmitting in the VHF range on cable that you bought specifically for HF? Now, I use, again, as I said, 213. 213 in the HF range, you know, is on minimal loss. But look what happens as you get over to the, have it is 100. Look what happens. You're at 1.9. That's 1.9 dB per 100 feet. My cable length is 120 feet. Add that 1.9 to the 4 that I already have from, the 0.4 that I have from my connectors, and I'm at 2.3, and then it's greater than that because that's per 100 feet. So I may be close to 3 dB loss between my cable and my connectors and the cable that I've chosen. Well, 3 dB loss is half my power at that. And what happens is, I think it's my gap tighten that'll tell you that you can try different bands. You can try 6 meters. You can even try 2 meters. Sometimes it just happens to resonate, and I've done that. But now I'm pumping 100 watts on 2 meters into that cable, and you can see what the loss is. So knowing what the dB loss in the cable is very significant. Recently, my club was given the opportunity to put an antenna up on a 600-foot tower. You're not seeing all 600 feet of it. We're up at 570 feet. Fortunately, there was a cable in place. If not, we would have had to run a cable almost 600 feet up the tower and another 200 feet from the tower to the utility shed, which is about where I took the picture from. So we're talking about 800 feet of cable. This is the kind of cable that we would love to use. Look at the loss as you get into, well, look at the loss straight across the board. It's exactly what you would want. This is per 100 feet. Minimal loss, even in the VHF range, UHF range, something you could live with. And you too could have this cable at your house for anywhere from $12 to $20 a foot. So not particularly practical for us, not particularly practical for my club if we would have had to lay out anywhere from $1,200 to $2,000, $2,500 or more to be able to run that cable. Okay, how do you choose the right cable? Frequency of operation. Know or get an idea of where you think you're going to be. Characteristic impedance, most of it's going to be 50 ohms, but people do use 75 ohms, and sometimes on receiving sides, they'll use the 75 ohms. They may actually get a better reception. Power handling, how much power do you actually think you're going to be using? Again, I was up to 600. Since then, I got rid of that and I stay barefoot at 100 watts. But make a decision. If you're first getting into it and you think you're going to buy a 1,000-watt amplifier, make sure that you're buying cable that can handle it. The distance to cover.
FCC proposes changes to the 60-meter band. The FCC is seeking comments about changing the secondary allocation available to radio amateurs on 60 meters. The FCC issued a notice of proposed rulemaking on April 21st, 2023 that deals with the band. In a prior petition, ARRL urged protecting the existing use of the band by amateurs when adding a new allocation adopted internationally. Currently, radio amateurs in the U.S. have access to 5 discrete channels on a secondary basis. Users of these channels are limited to an effective radiated power, or ERP, of 100 watts, CET.
Are you playing that message?
Allocate 15 kilohertz of contiguous bandwidth between 5351.5 and 5366.5 on a secondary basis.
Tom,
with a
we're picking,
maximum power
Tom,
of
please
15
mute. Thank you.
Okay. Yeah, that's a reminder. Don't forget you're supposed to have your radiation patterns in effect now, up to date. All right, so we're talking about the distance to cover. In my case, it's about 120 feet. I had a friend that had a big piece of property upstate, or actually in Connecticut. He had to run about 300 feet, and he bought 5/8 hardline. He was able to afford it, but for that kind of a distance, that's what he felt he needed. The flexibility. Also, where is it going? You need cables that are plenum rated for safety, to not be giving off toxics. Another interesting thing that, if you have a craft going out into space, facing the sun, it's at about 180 degrees Fahrenheit. The other side is about minus 469 degrees Kelvin. You need a cable, and now they don't actually use a cable in that situation, but you get the idea. Or more practically, an airplane taking off from Dubai, ground temperature 120 degrees, goes up into the atmosphere, goes up to 40,000 feet, and it's minus 40 degrees. You need a cable that's capable of handling those extremes. So again, we may not face that, but just something to be aware of. What kind of an environment are you living in? What kind of a cable do you think you might need? Now, we talked about the insertion loss. Again, everything that you put into the cable is going to give you loss. This is common sense. If your cable, if your transmitter is 50 ohms and your cable is 50 ohms and your antenna is 50 ohms, you're going to get the maximum transfer of power, and that is ultimately what you're looking to do. Let's talk about connectors, because this is really what got me started. I said to someone, now, you know, I told you I'm licensed since 1958. We use terms a lot, and sometimes we don't know what the terms mean. And I mean, I guess you should know, but how many of you know what BNC stands for? Well, I asked a few people. The best answer I got was actually a British nickel chrome connector. But in reality, when you do your quick research, you find that it's the bayonet Neil Councilman. And Paul Neal and Carl Councilman were engineers. Paul Neal developed what we know as the N connector. Carl Councilman developed what's known as the C connector. They combined the technologies to create the bayonet Neil Councilman. It's a spring-loaded connector, which is great for quick connect, not so great if you're jostling around, but that's the BNC. BNC has a cousin called the TNC, same kind of concept, but it's a threaded Neil Councilman. The N connector was a replacement for the PL259, well, an add-on to the PL259. To be able to get into higher frequencies, the N connectors get up to 11 gigahertz in frequency. And again, this is the connector developed by Paul Neal. And here you have a C connector in comparison to a BNC connector. Different size, different power handling capabilities. But again, both spring-loaded. Now here's another interesting one. What does PL259 stand for? And I'd be going, I was gonna say, I'm going to go out on too much of a limb to say some people don't know. But when you look it up, you find out that there is a Army Corps standard. And the PL259 was the 259th plug in that category, in the compilation of military equipment, military connectors. The SO239 was the 239th socket. I mean, sometimes something is just so obvious and we just don't even think about it. I want to point out something else though. In order to have this PL259, you see that there's actually something that's holding it in place, both on the male and the female. It's not just this pure opening. This changes the distance between the center conductor and the outside. And so a PL259 and SO239 are not actually 50 ohms. They're closer to 42 ohms. Now, again, it's only 1 inch. So is that going to affect you? Not really, except I have 19 of them. So I have more than 19 inches of 40 ohm cable. So that's going to throw me off even more. And it's a good reason why I will shortly replace as many of those as I can by running single wires and getting out of the connectors. This has become a very common connector. The SMA, sub-miniature assembly, used a lot on the HTs and such. This is capable of handling high frequencies, but obviously by its size, maybe a little more limited in power. However, as we'll see as we actually saw, when you deal with the insulators, the best insulator for dealing with heat is Teflon. So if you begin to make these connectors and the dielectric or the materials in them are Teflon, it is capable of handling higher power. Maybe not for a prolonged period of time, but if you had to do a test, it could be done. Some samples of various connectors. There's thousands of connectors because there's a connector for basically everything that you would ever need to connect from one to the other. Most connectors are made out of some base metal, usually brass, and then they're coated with something that protects them from the environment, protects them from oxidation. Some of these gold connectors can be pretty expensive. And the connectors that we were talking about on the hard line previously, they can run $60, $70, $80 a piece. During Hurricane Irene, which hit us maybe 2010, I think it was before Hurricane Sandy. This is a representation of something that I wasn't able to reproduce for this purpose, but I wanted to connect my HT to my outdoor antenna because I could then be in milliwatts, literally, hitting my club's repeater. All of my club's repeaters are backed up by generators. So as long as you can get to them, you're on the air. I could not find, and I always keep, in fact, in my drawer, I probably have 2 or 3 of them now for each kind of HT. I usually keep the cable that would go and allow me to go from point A to point B, from an SMA connector on my HT to an SO239 or a PL259. Couldn't find it. So I jury rigged, and this is only a representation of it. I had to go from, let's say, a BNC connector and start going through whatever I could put together to finally get me to the point where I had to be, which was either going to be a PL259 or an SO239. It goes back again to the fact that don't worry about putting in connectors if you have to do it. Try to avoid it if you can, but if you have to do it, you do it, and it worked fine. And I was on the air for milliwatts, and I was on the air for hours with my HT. It just never went dead. Here's some of the capacities of the connectors, the PL259, which is called the UHF connector, but it's really, not a properly named thing. Can go up to 300 megahertz, but for the most part, even at 144, you're pushing it. Why? Because as the frequency increases, the amount of heat that's being transmitted increases. And if you're running too much power at too high a frequency, you can actually get a PL259 to melt into an SO239. That's how much heat is actually generated. But you can see each of these basic connectors with how much power they can generally handle. So your choice of connector, and again, most of us are going to use a PL259, but if I were rewiring right now, why would I not put an N connector on the end of my antenna and run N connectors the rest of the way? My power handling will be better. My frequency response will be better. I don't have to worry about using it on a UHF. I also run a 1.2 gig. I wouldn't have to worry about any of those things. So your choice of connector is important. We mentioned the right angles. Again, just bear in mind, it's not a right angle as you're visually seeing it. There's a wire making a bend in those connectors. There are right angles for just about every cable and every adapter to go from PL259 to hardline. There's just one for everything. Some of them may be more expensive if there's less market for them, but again, right angles become an important part, especially as you're coming into the house and you don't want to make some weird bends to get into the house, so you use a right angle. All right, so choosing the right connector, again, same thing, frequency of operation, characteristic impedance, how much insertion loss. Now, I keep using 0.02, but good connectors are probably down to 0.02 and maybe even a little less, but cheaper connectors will have a higher insertion loss. Well, if you're only putting 1 or 2 in there, it's not going to affect you. If you have 19 of them, it can be a significant change. The gender, whether it's going to be a male or female, what kind of form factor is it? You're using a crimp, a solder. There's an area in which you get mixed sentiment. Some people prefer crimp, some people prefer a solder. Right now, it seems like crimping the braid and soldering the tip seem to be the most common way, or one of the better ways. You're getting a good, solid mechanical connection by crimping the braid. You're getting a good, solid electrical connection by soldering the tip. So your choice, but durability. You may or may not realize that every connector that you have has a mil spec. And in the mil spec, wait, that may not be a fair statement, but most of what you use will have a mil spec. The mil spec is, for example, PL 259 might be 250 openings and closings in which the tolerance must be acceptable. Because after that, as you keep doing that all the time, you're wearing down the metal, you're not getting that tight fit that you want, and so it will not perform the way you want it to perform. So the durability, well, for most of us, we put in a PL 259 and we leave it. I have some that have been in there for 20 years. But bear that in mind, the durability, then you have the environmental considerations. With connectors, water, moisture, you want to seal them. You want cables, you want connectors that are easily sealable. What kind of coupling style is it? Is it going to be a screw-on thread? Is it going to be a DNC type connector? And finally, cost. Well, if you're only going to be using 2 connectors, you're going from your transmitter to your antenna, whatever the distance is, buy a good connector. Don't waste your time with a particularly not well-made connector. They are very thin, they may bend, you may not get a good connection, a good solder connection, whatever. If you're buying more, well, make a decision. Or if you're putting more into your system, make a decision. But basically, buy what you can afford to buy. Don't try to cheat on it because you'll pay in the long run. A reminder about the losses. If you have 100 watts and you have a 3 dB loss, you have 50 watts. If you have 100 watts and a 6 dB loss, you have 25 watts. If you have 100 watts and a 10 dB loss, you have 10 watts. Well, coincidentally, how much is a 1 dB? Because that's a pretty significant figure. A 1 dB loss is 20 watts. So as you approach that 1 dB based upon the cable that you're using, or based upon the connectors that you're using, or whatever else you've put into the line, bear in mind that a 1 dB loss is about 20%. So if you're putting out 100 watts, by the time you get to your antenna, you're at 80 watts. Now, a lot of people feel that's not significant, depending on your antenna. 50 watts may not be significant, depending on your antenna, because your antenna, depending on what you're using, is capable of adding gain. So if your antenna adds 3 dB gain, then you're doubling your power. So if you have 50 watts coming to the antenna is a 3 dB gain, you have 100 watts. If you have 300 watts coming to your antenna, and your antenna is a 3 dB gain, then, or let's say a 6 dB gain, then you have 1200 watts because it's 300 doubled and then doubled. So 300 doubled is 600, doubled is 1200. So a lot of people say, don't worry too much about the power loss, but you certainly don't want to be at 10 watts, having given out 100 watts. And don't forget, where's that energy going? It's going out in forms of heat into your cable. So it can prevent other problems. Finally, the end. How did we do? I was just going to ask, how did we do on time? Because you want me to try to do that simulation for you? Or am I in your time frame now?
John, we okay on time?
Yeah, we're good on time.
Taking questions?
Yeah, we're good on
Yeah,
time.
let me see. Let me see if I can get it up here. Put my glasses on for this thing. I just want to make sure that it's not coming up when I do this. No, it's not. All right, let me turn this off.
And Michelle, you gotta mute. We're hearing you chew. Oh,
I'm sorry.
we
I was saying we were hearing you, I guess, chew sounds like potato chips.
Yeah, but just give me a second here.
Richard, while you're doing that,
Yep.
so that was, I really enjoyed this. This is filled in a lot of gaps, and it was very useful information.
I appreciate that. I've tried to make it from a logical point of view and stay away from formulas. A lot of times when you go to YouTube and you look these things up, the guy starts out with a formula and you get lost right away and you kind of lose your interest in it. So I really have tried to stay away from that. I want to make sure I'm in the right simulation here. Now I have to see if I can screen share with you. All right, do you see that now?
There you go. Yep. Yep.
Okay. All right, so normally I've been able to have this built and prepared so that it opens up with this, but this is a great simulation and they have great things for kids. Look it up, phet.edu, part of the University of Colorado. So I'm going to connect the battery again, just to kind of emphasize a DC circuit. You play with this, you get a little better at it. They always make the lamp part here short. So I'll put another wire in between here. Connect it up. And the bulb lights. So you see the flow of electrons. You see the bulb lighting. It's a consistent lighting. This is a DC circuit. And the only thing that's significant for our purposes in the DC circuit is the resistance of the wire. All right, now we're going to move on and build an AC circuit. And in this AC circuit, well, first of all, I've got to bring in my power. And I'm going to put a switch in there just for the sake of, where am I with my switch? There we go. Okay, now I'm going to put into this circuit a capacitor. I'm going to, let me move this out of the way. Of course, we want to be connected. And I'll put in another wire. Extend that out a little bit. Matching wire on this side. Now I'm going to put an inductor, a coil. And I'm going to put another wire to extend that out a little bit. And this wire we can just extend out. To make it more visible, I'm going to put another wire before I put the lamp on. The lamp will represent our antenna load. And we'll put a light bulb. And now if we're all connected, we're going to turn on the juice. Okay, now, First thing to notice is the speed before we get to the capacitor and the speed after the capacitor. It's not really what you want in a coaxial cable. It should be consistent from one end to the other. What happens if we change the capacitance? Let's increase the capacitance. Speeding up, slowing down. We decrease the capacitance, slow on all sides. Let's change the frequency because it's very slow frequency. As we increase the frequency, reach a point, see the flame starting to come? It can't handle the higher frequency, but look what it's doing to the rest of the circuitry. It's almost stopped.
This is a
We
great
increase the-
tool. I love this.
This is, and it's a great website, so enjoy it. As you increase the voltage, you can see again, you're putting too much stress on the system. If I decrease the capacitance, really not going to get anything out of that. But you can see what's happening. And again, this is not what you want to be happening in a cable. Now, when you deal with the capacitor again, as you increase the capacitance, the plates move closer and closer together. Well, that's that distance that we were talking about between the outer part of the inner conductor and the inner part of the outer conductor. As you decrease that distance, you are creating more capacitance. As you decrease the distance, there's less capacitance and a better flow of the circuitry. You notice how it's getting more balanced. Now, what happens if you play with the inductor? Well, with the inductor, as you increase the inductance, you're beginning to bring things to a halt. As you decrease the inductance, there's greater flow. So from this simulation, again, we're not talking about RF frequencies, but we're talking about what you can understand. You need to get that balance between the capacitive reactance and the inductive reactance so that the flow through the whole length of the cable, again, whether it's 1 foot, 100 feet, 1,000 feet, the flow through that cable should be consistent so that now you can understand if you apply 100 watts to a cable of 100 feet, how much power can you expect to be getting at the end of it? Again, the consistency of having 50 ohms with everything that we're doing. Of course, you notice that with the increase, well, first of all, with the increase of voltage and the decrease in the capacitance, we're getting the bulb to light a little bit more. I don't think we can get this bulb in this frequency and voltage. Actually, I want to do the frequency. See, it's almost a reverse thing. As I've increased the capacitance, I've cut down on the flow that gets to the bulb. And again, that's why there has to be that balance. And this is even with the capacitors wide apart. If I change that capacitance and I bring them closer together, if I increase the capacitance. Now, notice that the bulb is actually going better. Why? Because with the plates closer together, no, you know what, I apologize. Yeah, no. You know what, I left something out there. It's the frequency. Let me go back there for a minute.
Why are there
It was the
flames
frequency.
coming out of your AC voltage?
Say again?
Why are there flames coming out of your AC voltage?
Because there's too much resistance coming back in the wires, too much capacitance. Don't forget that capacitor is charging and discharging, and it's fighting that change. So that whole capacitor, considering that it was the dielectric in the cable, let's say this blue area is the dielectric in the cable. So that whole area is charging and discharging, but it's fighting itself. You know, it's going in one direction, it's charged positive, and then immediately going in negative, immediately going positive, going negative. And as a result, it begins to build up a certain heat factor.
Okay, so you just
It's
set
harder
your,
to charge the place.
you set it on fire then, okay.
Well, yeah,
I
know
got you.
I shouldn't do that to them, but the,
Okay, well,
Yeah.
no, it makes sense. Just curious why there were flames coming out of it.
yeah, and that will happen as you change. Well, again, the point being there, and now they're not showing anything regarding, let's say, the skin effect. But if this were RF energy, the skin effect would now come into effect, and as the frequency increased, the current is flowing more to the outside of the wire, and therefore decreasing the gauge of the wire, again producing heat, which can even melt the dielectric. So that's it. Every foot of your cable has capacitance. Every foot of your cable has an inductor. So now you have the capacitive reactance, which is that resistance to the change of flow. And the same thing here with the inductance. This is storing charge. This is storing current. And what happens is when you shut it off, notice that it continues until the capacitor is discharged. That's why your radio doesn't turn off immediately as you turn it off. The capacitors need to discharge. And of course, if you're replacing the starting capacitor in an air conditioner, you want to make sure there's no charge in there because that can knock you for a loop. Anyway, phet.edu, they have great things for kids, great math things, great puzzles, physics. They're always increasing, and it makes for a really nice simulation.
Yeah, that's pretty interesting.
How many
You know what I
posted?
do find interesting, and I was going to write them, they won't let me put more than one capacitor in there. You notice the capacitor disappeared. You can put almost anything else in there more than, well, it looks like the inductor disappeared also. They're only allowing you to do that. Can't answer why. But, another, well, let me get this out of the way for a minute. If you go back to this circuit, and we take out, I need my jumble map here. Let me take out the capacitor if I can get to it here. And I'll put the capacitor into the DC circuit. What do you think is going to happen?
It'll charge one time and stop.
And that's the difference between AC and DC.
Right.
AC, in this sense, is allowing not necessarily the current to flow, but the charge to flow. And the plates change. They go from positive to negative. The fields change. Magnetism comes into play. And it's like it's passing the electric, but it's not passing the electric. But a DC will charge once and then stop. DC is stopped by a capacitor. AC is allowed to pass. Any questions?
Rich, this is Michelle.
Hi, Michelle.
Hey, this has been a great presentation. I really appreciate it. You've taken things that are very complex and just put them in really practical terms that all of a sudden, all the other things, that we're confused about are beginning to make sense. One thing that came up earlier this week, you can buy PL259 to SMA connectors, as well as SC239 to SMA connectors, is one piece where you have like the PL259 on one end and the SMA on the other end, or you can buy those same connectors with a piece of cable in between. And my first question really was, well, okay, what am I losing for that cable and what are the limitations? And I didn't see that information immediately available. And obviously the cable is in there to lessen the stress on the two devices that are at the other end of the connectors. Can you kind of talk about that a little bit? And should we use the connectors that have a little bit of cable in, or should we try and get the one-piece connectors and be very gentle with what they're connecting to?
being gentle with an SMA connector can be a difficult kind of a thing. It's very easy to cross-thread an SMA connector, even when you're putting your antenna back on there. Also, when you look at your SMA, which is mostly in your HTs, they use them in other purposes, but mostly in your HTs, it's very fragile. You know, it's mounted onto a piece of plastic on a unit that doesn't have a particular amount of weight. You want to avoid any weight coming down on that. So in the case of going from an HT to a 259 or an SO239, you always want to have that length of cable. And it's usually about 1 foot long, and you know, it's an HT, you're only putting out 5 watts or 10 watts or whatever. Loss is minimal, if anything, but you don't want to put stress on the SMA connector.
Great, thank you very much. I found some with cables as short as maybe, I think maybe 6 inches, and they seem to work out especially well. And especially becomes an issue if you're using the Nano VNA system that has the SMA terminals. So thank you very much. It's been wonderful.
Yeah, just bear in mind, 6 inches may not be enough to take off strain relief if you're connecting right then. I have, I forget what I have coming in the house on my UHF VHF. Probably almost RG8U. If I'm 6 inches away from my HT on a thin cable with RG8U, I still may damage. You know, the weight of it may drop down and still do some damage. So always have that relief cable. Also the same for the reverse SMAs, and if you're doing anything with Motorola's or whatever, try to avoid the strain on the HT.
Thank you very much.
Okay. Anyone else?
Yeah, I got a question. So for an FM radio station pushing 100,000 watts, 24/7,
Right.
what kind of cabling would they use?
Well, some of them use pipe, and some of them use waveguide. I used to, when I would do a demonstration at Henrietta University, one of our members who was the chief engineer for one of the radio stations up here would give me a piece of pipe. And pipe could be 4 inches, could be 6 inches. The dielectric is usually a gas filled. Again, there's no center. And those are the things that are capable of doing 50,000 watts and then some. I also, talking about space for a moment, talking about the higher frequencies, talking about 300 gigabytes, you know, I think I'm trying to think of the word. The 5 that we're using on our phones now, that's at something, I think that's in 30 to 40 gigs. And 6, when they use that, is going to be up in 90 gigs. And there's a lot of stuff to consider in how much radiation is coming out of them. 300 gigs and some of the really high frequency stuff that might be used in satellites and space adventures, they may be using waveguide in those things, or something else that's not susceptible to the extremes of temperature.
So when you say they use a pipe, is they actually using the pipe for the RF, or do they put a cable inside the pipe? Sorry to sound so dumb, but
No, what are you saying, the pi?
we were talking about an FM transmitter pushing 100,000 watts, 24/7.
Right.
And you said they use a pipe. And so my question is, in my mind, I'm picturing a copper pipe. Are they using
Yes.
actual pipe for RF, or does that pipe have something inside of it? Like a cable?
No, the pipe is handling the RF.
Got
It's
it.
got a semiconductor that's, you know, a tube of aluminum. It's got an outer conductor, not whatever they're using. It's got an outer conductor. Inside between the two is the dielectric that's filled with gas. And yeah, no, that's handling the power. But within even those pipes, even within a 4-inch or a 6-inch or even larger pipe, they will have adapters, because obviously if you're going to take some reading, you're not taking a reading off of 50,000 watts. You need to be able to reduce it down to something that's handleable, and they'll reduce it down to an end connector. to be able to take some readings off of it. But it is connected through pipes.
That's interesting.
What's interesting too is I went to visit a radio station and they have a 50,000 watt transmitter. And I don't know that I'd ever seen one before. Wasn't much bigger than a hat box.
Well, they're small now. They used to be a lot bigger.
Yeah, but the cooling behind them is enormous. I guess it's glycol tanks behind them to cool down the 50,000 watts. So it's not like you have a 50,000 watt transmitter and it's in a case, 4x4. Behind it are probably 8-foot cabinets by maybe 10 or 12 feet. And that's the cooling to make sure that it doesn't overload.
Yeah, there's a YouTube video that I was watching these station engineers from, it's a 50,000 watt AM station in Los Angeles, 6:40 AM. The call letters, I can't remember them, but anyway, the guy was showing, they had the young guy and the older guy, and the older guy started in about 1940s. And he was showing the transmitter from 1940. The thing took rooms, just huge. And then they showed the transmitter that they're using now. I think it was a Continental, but anyway, it was just a cabinet, not that big.
Yeah. Well, again, you only saw the transmitter part. You didn't see the cooling necessary.
Yeah, probably not.
That's a big difference in the mechanical makeup of it. Certainly a lot of changes there. Fascinating going to a TV station. The one that I went to has 2 of its own channels, and it's also hosting 3 other channels. And one of the things that they have to do is to have redundancy because they don't want to be off the air. So they may have over-the-air communications, they may have additional satellite communications, and they also have linking. And I believe now just to mention my club for a moment, we have a receiver in the Empire State Building on the 79th floor. I think that's in the 800, 900 foot range. 63 miles away, we have an antenna at 570 feet on the tower that we're talking about. We're okay with our link, but some of the TV stations may take 5 links. They call them hops, I think, 5 hops, because there may be a mountain in the way and they're not going to be able to transmit through the mountain. So they go around the mountain by transmitting to one tower, which then transmits to the other, to another, again, going completely around the mountain and then coming back. And is there a latency? Yes, there is a latency, but you don't know it. The person at the other end doesn't know that it took a slightly longer period of time to get there, and you don't know that it's taking a slightly longer period of time to get back to you. So I found that to be fascinating. That's why so many radio stations have towers in other locations. That's for their ability to get the signal out, to get from one point to another, should there be a complete breakdown of the system.
Yeah, that station's KFI in Los Angeles. I'm thinking of, I got a list here. But anyway, when you have I may be asking you questions that you're not really, this isn't really our subject matter, but when you have a tower with multiple transmitters on it and you want to work on something on the tower, do you have to shut all of the how do they do that? Do they say from 1 in the morning till 4 in the morning, everything shut down? How do they do maintenance on that? I know AM usually have one transmitter, but a lot of FM transmitters can have multiple. We've got one off of Briarcliff Road that's got 10 or 12 FM transmitters on it. So how do we work on that?
Yeah, it's an interesting point because the tower that we're on, that one tower, by FCC regulation, had to change its light, I believe, to LED. I think that was the major thing. And that's the lights going all the way up the tower. They did not, to the best of my knowledge, shut off the FM. We're putting out 60 watts. Maybe there's some calculation of the inverse square law. although the tower may not have been big enough for that, maybe they're shielded in some way. I can't answer that. They did not shut off all of the systems. They did shut off the high power stuff for an overnighter when they finally had to get up to the very top of the tower to be able to change the bulb on the very top of it. But coincidentally, when you do a tower like on the Empire State Building, where it is all radio waves going through there, it's in sections. And they actually shut off a section of the antenna as you're moving up so that you can move through the antenna. They don't really want to go off the air, but they reduce power and have you walking through various sections of the antenna.
Yeah, interesting. Thank you.
You're welcome.
I may have gotten off subject there, but you
No,
said
no,
you might know it.
Well, it's really all part of it because it's all RF. And, you know, like I said to you, my neighbor, after I had my antenna up, put up solar panels. It's definitely interfering with my signal. I have a fairly high noise level coming off of it. When we put our antenna up on the tower, there had to be considerations for other things that are nearby. One of the local radio stations had a problem with some of its equipment because of the rotating light at the top that was causing some interference. And how did they know? They began to time it and they said, what is going by this time? And they looked up and then they saw the light, and every time the light went a certain position, it was causing RF interference.
Yeah.
So
We have a club here in Metro Atlanta that their tower, their repeaters on a tower, and you can tell when they have their net about 8 o'clock at night, and everything's fine until the strobe light comes up on the tower, which FCC requires them to have, because you can hear then it goes off every so often, so you can hear the strobe over the radio.
you know, the worst thing also is when you're on a tower and you have other stations there and you get some intermod, because the intermod can be caused by so many different things, frequencies below you, frequencies above you, you know, and that's a real problem. We've had that happen. In a few instances, we were able to change the PLD code and avoid some problems. But in one instance, we actually had to change frequency, which we were able to do at that point. But you never know, and it's all RF. And the interesting thing about RF is that many of the members of my club and friends are engineers. You know, I'm from Long Island, the home of Grumman and Fairchild. Many of them work for those companies, very knowledgeable people. You can ask them certain questions in RF and they'll say, I don't know. I don't know. It just works. It's what it does. I don't know why it does it. Because when you think about all the things that are going on in that cable between the magnetic fields and the, you know, remember that the flow of electricity is in one direction, but the charge is flowing in the other direction. And why is that? Because as the electrons move off of the atom is left with a proton that's not balanced with an equal number of electrons. So it becomes positively charged. And therefore the negative charge flows towards that. You know, it's way above my pay grade, but just think about all those things that are going on in the cable.
Yeah.
That's why it was fascinating. And as I said, for me, it started with the connector. What was a BNC connector? So now at any party, without a drink, I can tell people a BNC connector is a bayonet Neil Councilman. And I'm telling them the hit of the party.
Thank you, Richard. Good
You're welcome.
presentation.
Yep, my pleasure. I'm going to sign. I have a dog that has a weak bladder. Does anyone have any other questions?
Anyone out there? Anyone?
Thank you much, Richard.
You're welcome. I'm going to disengage and walk my dog. And as I said,
Richie, thank
maybe
you.
we can plan a joint session at some point. I think it'd be maybe really interesting to have your members talking to our members, common problems, and you know, we're all facing the same thing, and that's why the ARRL sent out that note about raising dues, and you know, what are we going to do? It's the only spokesman we really have, but we'll see. Anyway, guys, have a great time. Thanks for inviting me.
Thanks so much, Rich.
Very much.
You're welcome.
Thanks,
Thank
Richard.
you.
Thank you. Thank you.
You're welcome.
All right, Rob, thanks. Another great program. It's about 9:15. Does anybody have any last minute follow-up questions from tonight's presentation they may not have gotten answered?
I have a fast question. I've been coming in on Echolink for the Sunday night net meetings. And I'm trying to expand what I'm doing and learn, new digital modes and things. Is there any other way that I should be learning how to come in to the repeater from New York?
That would be your only other way, I would think, at this point.
Okay, that's fine. I just, if there was something else that I could be playing with and learning, that's what I wanted to, start, trying to study that.
Yeah, I think that's your best bet is Echolink.
Yeah, we used to have something else. Can't think of Rob. What was it that we used to have on the
IRLP.
IRLP? Yeah, which was different, and it would dominate the repeater. So Echolink works really well. I mean, just many people can use it.
Yes, Echolink is great. No complaints about Echolink. I was just trying to explore and see if there's anything else that I should be learning about. That's all. And it works great, and I'm happy with it. And I certainly wouldn't want to, in fact, it's working great, and everybody's happy, and there's no reason to change it or expand it or anything like that. But I just wanted to ask. Thanks so very much. I thought this presentation went well, and I hope we can get together with. Link the Atlanta Radio Club and Limark and some of the other Long Island clubs together, because I think the New York clubs could learn a great deal from what the ARC is doing.
Yeah, definitely we can learn from each other.
It's a good question, Michelle, and maybe at some point we might have, because there are some possibilities out there that might come around in the future. But yeah, for now, Echolink is it.
Well, I mean, when we go to DMR, if and when we get DMR and or D-Star hooked up to the net, then Michelle, you'd be able to just hit a local D-Star or DMR repeater up there and hit us, through the local repeater.
Oh, right. That's the sort of thing that
We don't have that capability. Yeah, so
that's fine. I've written it down, and that's one of the things that I'll look at and watch some YouTube videos. Certainly do not do it just for me.
Check out DMR. It's pretty interesting. And it's got a lower cost to buy a radio than D-Star.
I think I have them, I think I have that part covered.
Because ICOM's the only one that sells the D-Star radios.
Oh, okay. Well, I'm kind of a Yaesu person.
Oh, then look at Fusion.
All righty.
That's their linking repeater to repeater thing.
Yeah. I when I was answering your question, I was thinking about what our capabilities were. There are other ways of doing things, but yeah, that's Echolink's probably your only option at the moment. So,
well, it's a good way to start off. Thank you very, very much.
Yep.
And I will get rid of this dopey photo. This, it was raining cats and dogs. I didn't get my makeup on and I look like hell. So I'm using it to cover up. Y'all look handsome and great. I don't look so great. So that's what I'm using the dopey photo for, right?
That's why Zoom lets you, just have a static photo in place of the video feed.
Well, the photo just makes you look like you're amazed at the presentation.
Yeah.
It's fantastic. Well, that's what ham radio does for me. I mean, I'm just so fascinated by it, and I love doing it. And it's been an incredible exploration. I'm 73, and I'll be able to learn new things, forever. I mean, I'll never catch up with all the things I have to learn, and I just find it fascinating, and I just love it to death, basically. And people think I'm a little bit loony, like, lady, why do you have all those radios? What are you doing?
73 is the ham radio code, right?
I'm sorry?
73 is what people use at the end of QSOs.
Yes.
73, yeah. So you share that.
Mhm.
Hey,
Well,
is anybody, I think about going, is anybody going out to Mud Hill at Brook Run Park on Sunday afternoon? I think I'd like to go. Bill talked about it last night.
I'm thinking about it.
Oh, okay.
I haven't ventured out for a long time, so I was thinking about going over there. I haven't seen Schiff in years, so.
You mean we're gonna have an aid sighting this weekend somewhere?
Yeah. Out at Brook Run Park.
All right.
I think 2:00 was the time I heard.
2:00, yeah. 2 to 5 was what Bill said.
Yeah,
Okay.
There he is.
just so we'll, unmudded. David Schiff just bought a new radio, and Michelle, he, based on the fact that you bought mine, he bought a 991A.
Yeah.
But I don't know if he got a new one or a used one. But in any event, we agreed to do Sunday the kind of thing that you and I did, just take the radios out, set them up, put up an antenna, and play with it for a little bit. So anybody wants to come out to Brook Run, just come on. Just be aware, I don't think it's an official club event. I will have the standard snacks and some water and soft drinks, and Rob, I'll have Diet Dr. Pepper. So
Thank you.
and I'm thinking, we get there about 2:00 and set up and fool around for 3 or 4 hours. And there are several QSO parties that are happening this weekend as well. I give a list to the guys at lunch at dinner Tuesday. So there ought to be quite a bit of activity going on. So that's kind of the idea. So there's no goal to this. It's not a club event. It's just, I felt like getting out in the park with David and playing radio for a couple hours. And Arnold has said he will not be there. Judy won't give him permission to leave the house. So it'll be quieter. There won't be any POTA activity necessarily.
And this is Bill Perkins.
Yes.
Oh, Bill, I cannot tell you how many times things that you taught me while I was there in Atlanta have come up. And even like on this past weekend, Monday, the wonderful wire stripper that you showed me, and I went and bought one just like it. They were building an antenna at the NARC club. And so I pulled that out, and it was just a big hit, and people hadn't seen it before. And these are folks my age and older. And it was just, there were so many things like that you taught me. And the drive all the way from Atlanta to New York, I was going through my mind about the way to twist your wrist in order to coax correctly.
Oh, yeah.
So I should have that nailed by the next time I could get back to Atlanta. And I'd love to be there in Atlanta for this weekend. I've had some health issues that I've got to get through first before I get back.
Some people never get that coiling of the wire correct.
That's me.
Yeah, they're saying Arnold has a way of doing it that ends up, I just say, thank you, Arnold. And then when I get home, the first thing I do is pull the wire out, throw it out through my front yard and rewind it correctly. Because his comes out looking like a pelican nest by the time you try to do anything with it. And as far as those wire stripper goes, I don't have a clue where I ran into those, but it took a while to find them. And when I finally found a source, reasonably priced source, I bought like 8 of them. Mm-hmm. So every toolbox now has at least one. And you're right. I had never seen them until just a couple of years ago, and it absolutely beats anything I've ever used for stripping wire. So I'm glad you were able to impress your friends. And that's good.
Remember, I am the only female face that shows up at Linemark and or NARC. So I'm like an alien or something. But let me ask another question. Your audio is especially good. Are you using a special microphone when you're speaking?
Who, me?
Yes.
No, it's just I've tweaked the settings. I used to, in my management role, have to have a lot of meetings with people, and it was important for me to be the loudest voice in the room.
Loud, clear, and authoritative.
Right. When the subordinates began squabbling, I could say, "Let's be quiet now," and and the bass tone would carry. So yeah.
Are you using the mic with you have a new 71 something or other?
Nice.
No, I'm actually on the computer.
Okay, on the computer. All right.
Yeah.
And with a and then that's just with your video connection?
Yeah, I'm on a Zoom meeting. I'm just using a headset, but it's
Oh, the headset.
like I say, I went in and fiddled with the settings, and this was years ago. I fiddled with the settings so that when I had to have a meeting, so whenever I took over a new project, there was usually a lot of contention going on, and I'm the guy who had to come in and so you hear I have a Southern accent. In the early days of dealing with them, I would punch up the accent, really lay it on thick, and use words like pilfer and I reckon and we'll see. And then once I had figured out who was who, then I would shift into management mode and take on a more Yankee personality. But the microphone sort of helped with the God has entered the room sound.
Well, it does it very, very effectively. May I ask what kind of mic you're using?
I'm using a Creative mic, but it's been modified just a little bit. So it's basically not a stock over the counter headset, but it's pretty close.
It is very, very effective. That's why I'm questioning you about it. And I
Thank
did
you.
the same thing because when I moved south, they told me I had to learn how to draw. And if you're going to fight with good old boys and win, you got to sound like one.
Well, I figured coming into a project that's already failing, I would
Yep.
rather be underestimated for the first couple of weeks,
You have to be.
because in everybody it's going to be ass will be an ass in front of me thinking I'm not smart enough to figure it out.
Mhm.
And I would typically work for a couple of weeks as just a plain old developer. Y'all going to lunch today kind of thing. And then whoever hired me, the owner of the company, the department director or whatever, we would have a come to Jesus meeting. And suddenly this buffoon or rube that's been sitting in the back, he's the new boss.
I hate when that happens.
It would get real quiet in the room.
Mhm.
So, and with Zoom meetings, I had to have a little better presence. That's enough about me.
Well, it works very, very well. It's quite impressive. A+++. Superb.
So you're not going to be at the park Sunday?
Well, I guess I can get on an airplane. I'm kind of stuffed up and I have a couple of things. I have some good medical resources up here that are all right close together that I don't have to drive for.
No, don't worry. It's just that everybody has to meet David Schiff at some point.
Yeah.
So
He's a
you'll
lovely character. Yeah.
you'll see him next time.
Okay, I've heard about the great David Schiff, but I haven't met him yet. I don't think.
Oh God. All right. I'm gonna mutt again. It's good talking to you, Michelle.
Hey, good talking to y'all too. Thanks so much.
What are we doing over here? Oh. Go ahead, John.
That's about all I have for the evening. So they got a good presentation tonight.
Got the Friday lunch coming up on Cinco de Mayo.
Yeah, Friday lunch. Oh, that's right. That's right.
Hey guys, FYI, that stripper device for stripping wire insulation, Micro Center has those.
Yeah, and I sent the link to Rob of the
You
one
did?
I have from Amazon. Only mine is like 27, 28. And I think, I believe Bill said he was able to get a bunch of them for like maybe $13 or $14 on eBay. But that's something which I'd never encountered before. So, and I only needed one. They're heavy enough so I can't have one in every box.
I'm going to buy two because I always lose one.
Oh yeah, I always get
Yeah.
backups.
Where's the Micro Center's got them too? That makes
Yeah.
sense. Where are they at Micro Center? In that room with
In the tools aisle.
the one in a separate room?
No.
One
Towards
over
the
by the
center.
PC?
One of the center. No, not by the PC either. Up front, not too far from the registers.
No?
One of the center aisles.
Now that you've said that, I'll swing by tomorrow on the way home from work. Michelle, I only live about less than a mile from that Micro Center. I'll swing by and see if they've got any, because like I say, I bought one and threw one in every toolbox because I was doing the Boy Scout thing up in Western North Carolina. And so I might have 3 or 4 different people building antennas at the same time. I needed 3 or 4 of them to spread around, but I didn't want to pay a lot for them because if you put out 5 or 6 to use, at least 2 are going to walk off.
Absolutely.
So if you go to throw something away cheap.
That's what Harbor
Write
Freight.
your name on them too.
I do. Doesn't help.
Yeah,
Which,
And I know
Okay.
I know it's not intentional. It just, they get mixed in other people's tools and they get gone.
We got to do an antenna thing one of these days. An antenna build. We would have been good at the Hamfest, but remember Skip did one last year at the Hamfest. That went well.
Yeah, it was well received. I think it was an end-fed antenna.
Yeah, I think that went well.
Yes, Bill, Rob has spoken very, very highly about your antenna presentations and how popular they were and how they brought people in from all over the Southeast and North Carolina and Alabama and everywhere.
Hear the
because
famous Bill, yeah.
Yeah, they've heard of the famous Bill Perkins and the antenna, the opportunities to leave with a working antenna, which for a new ham is a really, really attractive thing.
That's one of the things that I like to do with the Boy Scouts, and I'm not going to be able to do it this year because the dates don't work out. I'll be coming back from Florida on the day of the Hamfest, so we'll probably do it in the fall. But I take a couple of radios and I take enough boxes. I've got my antenna construction kits in plastic boxes, and I'll take like 3 of them. And so the deal is, we'll go through the mechanics, the logic, the math of building it, and then we'll actually do the mechanical part of building it. And then you take your antenna right across the other side of the field, hook it to a radio, and use it before you leave. Wow. And they get, I think they get 2 merit badges for that, one for the construction and one for the use.
Slick.
And it's pretty cool to see a 10-year-old kid, something he just built, and he's talking to some guy in Indiana or something. That just always impresses me. And then some kids get it and some don't. You can tell.
Hey, Bill.
Yes, sir.
$11.99 at Micro Center. I looked up my receipt when I bought it. So
that sounds pretty cheap.
Okay,
that's pretty good.
Which Micro Center was that?
Duluth.
Oh, okay, that's why I was thinking of the Marietta one.
Well, they probably have them too.
No, I know, but I mean, as far as the location of with the tools.
Yep.
I haven't seen them here in New York, but our Micro Center is very small in comparison to what you have there. But it's right close by too.
Yeah, there's one in the area there. I remember that.
It's on Merrick, right close to the opening of Eisenhower Park.
Yeah, I think my brother went over there one time. All right, sounds like anybody else for anything? Any random comments on anything?
I'm done.
See you at lunch tomorrow.
Yep.
Thank you so very much. I've been thinking of y'all, and I'm sorry I can't be there in person, but I hope to get down there again very soon. I needed to, my house is waiting for me. I have to get that straightened out.
Just give us warning when you're coming.